Okay, so great to see everyone back, seeing everyone looking nice and energetic after these coffee discussions. So we had a really nice introduction this morning showing like the EHDS is coming. What does this mean? And data holders beware, you need to prepare your data. Then we saw a really nice example from America, from MSK, uh, on how you can make your data available for research purposes. So yes, we still have the question like, how will we do this in the Netherlands? How will we do this in Europe? But one of the first questions is like, how do we in the Netherlands, for instance, use cBioPortal? So we have a few speakers today, starting with Sam de Vos from Prinses Maxima Center. We'll first showcase how are we using cBioPortal as a tool, for what purposes, followed by some nice presentations from C4Bio and the Hive, but that will follow later. Sam, the floor is yours.
You. All right, good morning, everyone. Thanks for being here. And thanks for the organizers to give me an opportunity to talk a bit about cBioPortal as we implemented it in the Princess Maxima Center. I've been a bioinformatician in the Princess Maxima Center for the last 4 years, where I did some research, but also been involved in the development and maintenance of platforms like cBioPortal. So thrilled to talk you through how we have implemented it. Let's see. So for who doesn't know the Princess Maxima Center, we are the pediatric oncology center in the Netherlands with the shared goal to cure all the kids in the Netherlands with the optimal quality of life. And what I think, I won't go into too much of a background from the Princess Maxima Center, but what I think is important to realize is that since 8 years, we have been situated in Utrecht in a central building in the Netherlands. And before that, the Princess Maxima Center was actually a group of people that were scattered over 7 different centers. And 8 years ago, we realized that having such a niche specialization field, because there's only 600 new kids diagnosed per year in the Netherlands, we really needed to combine all the expertise in one single center. And doing that relatively recently really gave us the opportunity to make the interaction between the clinic and the research as close as possible, and also to streamline the data flow and the processing as much as possible. So going into a bit more detail about that, this is the kind of hospital data that you would expect in a clinical setting, right? Because we are an oncology center, we work a lot with genetic data and also the patient data, the samples, and all the concepts that are bound to that. And 8 years ago, when we put everything in the same center, we decided to put up a central identifier policy that talks in a very consistent way. There you go. Oh, you guys were seeing that. Okay. So we have different types of concepts that we are describing, and we're doing it in a very consistent way. This doesn't sound very high tech, but I guess that people will appreciate this, especially if their center does not use such a centralized policy. Because this really allows us to integrate a lot of data, which I will get back to in a bit. So we store this kind of data for each patient, and if you combine all that, if you combine that for all our patients, then you come up with a biobank full of information. Currently, we have more than 5,000 patients for which we have elaborate genetic and transcriptomic profile available. Whole genome sequencing has been used for research for a long time, and since this year, it's actually the standard of care in our institute. So that's great. It's very rich data. We have a lot of data available, and whenever there's informed consent by the patient to use this data for research, we will put it in our cBioPortal instance. And if there's actually a need for more detailed information than the unprocessed data, then we have to go through a request to an official committee so that you can do more in-depth research. Since we have this centralized identifier policy, we are able to integrate this data with all sorts of clinical and preclinical data. So you can imagine that there's a lot of domain-specific or tumor type-specific data sets that we have, but we can also think about an organoid biobank or a single-cell core facility that makes their own data and that uses the same identifiers. So we have this one single metadata platform where you can click through this kind of data and build a cohort, which is called Discover. And from there on out, when you've selected your cohort, you can actually link out to cBioPortal to really dive into the genetic data underneath. And because I don't want to mess with the demigods, I made a small video instead of doing a live demo. So this is an example of our platform, our Discover platform. And in this case, I will start looking for a patient that has undergone a specific type of stem cell transplantation. And then I will hover through different dashboards to click for all sorts of information. So I'm looking for patients that only have one diagnosis associated. And I often am interested in a specific type of diagnosis, in this case, Ewing sarcoma. And I might be interested in looking for patients that only have a specific sort of extra data available. So a full body scan in the radiology department, for instance. And then when I've made my selection, I will go to a plugin that we developed internally that links out to cBioPortal. It will need some time to think. Computer's now making an URL, and then you can click through, and you will be ending up in our own cBioPortal instance, but then with the cohort that you selected in another platform. So that's basically where we start our cBioPortal exploration. We do a lot of cohort filtering outside of cBioPortal, and then we can start looking into the genetic data. The main reason to use cBioPortal in our institute is to do like a preliminary analysis to check, do we have enough patients to really tackle this research question, but maybe also to extrapolate findings that you find in a very specific cohort. Does this also apply to other patients maybe? And like I said, you might need to have more data that we on purpose do not all put in cBioPortal. A little bit of background why we chose to go for cBioPortal as an implementation. I think that for all the tools out there, cBioPortal is relatively easy to understand. It's intuitive, and the learning curve is not too steep. It's important to consider that there's an active community behind it, right? This is also why we are here. You don't want to invest or build infrastructure based on a tool that's supported by a single research group that might not exist in a couple of years. And for us, it really fitted the purpose to do a preliminary analysis, and that every clinician, for instance, with a little bit of explanations can also use this platform. So a little bit of on the data side, how we decide to use cBioPortal is by doing full data releases on a monthly basis, which gives some sort of static snapshot of all the information that is available at that time. I think that this is the most user-friendly way to do it. This is also how people can trace, for instance, when a sample is no longer available, when it got removed, and then maybe ask a bit more about what the reasons for that was. Getting the data into cBioPortal is also a quite automated process on our side. We use a workflow manager to transform whatever new patient's data is available on a monthly basis. So there's very little manual steps involved. Typically, a workflow like that takes between 1 or 2 hours, which is fine if you have to do it on a monthly basis. And we also provide the end users with a little bit of background, what has been changed since the last data release. That can be a change in the software version that we used, or samples that have been removed because we want to clean or increase our data quality, for instance. The data content is quite aligned with what we have in our biobank. So our RNA-seq data is used for fusion data and expression profiles. What we use for our whole genome sequencing is everything that relates to the coding aspects of it, right? So that we are looking into somatic single nucleotide variants and small indels, but also with copy number changes. And since recently, we also use the structural variants of it. And then we combine that with the high-level clinical data, which we don't put too much effort in because we actually do this kind of filtering in our other system. So a bit more about structural variants, because this is actually the the one item that we have been developing quite recently and that we are excited for. Chromoscope implementation, some people might have heard of it. It's a relatively new feature to visualize the structural variant data that is available. And this aligned really well with our recent developments to automatically also call the structural variants for each patient. So yeah, perfect timing, I would say. We are thinking about the integrated view because Chromoscope is able to show you both structural variants and the single nucleotides as well as the copy numbers in one go. We are currently struggling with how we need to change our ETL processes because it requires different kind of data than what is already in the cBioPortal instance, right? But I'm sure that we are getting there. And since very recently, there's actually plans to also integrate the Chromoscope plot in the tabular view that's already in cBioPortal, which we currently only use for showing fusions on an expression level, so that people can also see the interplay between transcriptomics and whole genome sequencing data. I don't want to go into too much detail here because I think there's a special, okay, perfect. There's a special talk to talk more about multi-institutional instances, but it's good to mention that we are actually in the process of setting up a shared cBioPortal instance between 7 different precision medicine programs scattered over 7 different countries. So we are currently experiencing all the difficulties that were already briefly mentioned this morning about how what comes about when you're integrating data that comes from different institutes and the different ways for how the data was generated. And for us, I also decided to put in a little bit of what we are currently struggling with on the content side. In the current version that we have implemented from cBioPortal is very gene-centric. So there are some research questions that people are eager to solve that are simply not available right now, and most of it is non-coding variants. You can also imagine that the single cell facility is very keen to integrate something, but what I heard from Niki is actually that this is already optional, so I should definitely learn more about that later. How I see cBioPortal and the way we have implemented this is really a visualization endpoint. We haven't played around too much with the API, so maybe there's more data wrangling opportunities there to actually also use it as an intermediate system to mold the data into something that is useful outside of cBioPortal. We are currently not doing that too much. And these kind of developments we are also a bit hesitant about because we are purposefully keeping cBioPortal as a preliminary analysis tool. We do want people to actually look for their ultimate findings in the raw data to make sure that we are talking about the same things. So we are always striking a balance, like how complete do you want the data in cBioPortal and how intuitive do you want to keep it? That's my presentation for now. There's a lot of people to thank, all the people in the team in the Maxima that are involved in developing cBioPortal, but also the other Discover platform, all the collaborators, and of course you for your time.
Thank you. That was a really nice presentation. First, are there questions from the audience? We have a few minutes.
Great presentation, and yeah, really cool to see what you're all using, and really cool to see that you're using Chromoscope as well. I was curious, like how you're getting the data in right now. Like you were talking sort of about the different ETL processes you have. So was a lot of the structural variant data that you have already sort of in the right formats to go into Chromoscope? Like was it that PE or something like that?
Well, I must say, we are in very early phase. So we manually did some of these transformations, and now it's not a very sophisticated pipeline yet, but more of a compendium of bash scripts. It actually was not too bad. It was actually quite comparable with the typical output that we have for structural variant data, which is nice because there's not really a consensus of how you make structural variant data, right? There's more of a consensus for SNVs, for instance. What we are struggling with is that structural variant callers are not very, there's not a golden truth structural variant caller right now. So our current implementation does a consensus call between different SV callers. And then you end up with the problem that they all have different breakpoints, for instance. So then how do you decide which breakpoint to take? And these are kind of the struggles that we're still puzzling about. And there's probably not a perfect answer for that.
So just one more question. Raymond, if you would already come to prepare.
Thank you, Sam. So I don't know much about the Discover platform, but what does Discover achieve in terms of cohort building that cBioPortal doesn't do for you guys right now?
Yeah, that's a good question. Discover is a very versatile platform. So you're able to model the integration of a variety of data silos. So for us, that's really a nice tool to integrate all sorts of clinical data that are scattered throughout the institute. We also think that the integration of that data is not only useful in a genetic setting, right? So there's a lot of use cases for which Discover is used that people don't click through to cBioPortal. I guess that you could make all sorts of clinical enrichments and extra tables in cBioPortal, but I think that might also deviate a bit too far away from what cBioPortal is used for. There's, for instance, we also have data about questionnaires that patients have filled in, and that doesn't make too much sense to put in cBioPortal, just as an example.
Okay. All right, so due to the time, I would like to give the floor to Raymond Fijnman.
Before that.
Oh, dat bedoel je. Ah.
So, again, congratulations on successful defense of your PhD yesterday, and maybe even more important for giving us the excuse to have the cBioPortal Symposium today. So happy to talk about how we apply cBioPortal in context of the prospective Dutch colorectal cancer cohort and the ctDNA studies. So I'm Raymond Fijnman. I do biomarker research, and basically I just traveled the path from molecular pathogenesis to clinical implementation, and I really like this research part. So I work on colorectal cancer, and here you see a bit of an example of the patient journey where we simply need to ask 3 simple questions. Who needs treatment? How should this treatment look like? And when do we need to adapt this treatment? And in terms of current diagnostics, one could argue we are not doing a really bad job, but in fact we are doing a relatively bad job, and we really need to improve diagnostics. And here there's one nice opportunity in context of circulating tumor DNA to at least improve the current standard of care diagnostics. I will not explain a lot about ctDNA now. What is important to see is that when you then look at the translational research, you play with DNA alterations, with DNA technologies. Times have changed very quickly. For instance, if we do a minimal residual disease test now, we do 80 times coverage whole genome sequencing on paraffin, 40 on whole genome sequencing of the germline DNA, 30 times on the cell-free plasma, which I think 10 years ago was almost unimaginable. So great to see how many data that we can collect and put in these studies. But the translational research part, although it's the fun, it's not necessarily the basis of what we are doing. What we are discussing is actually access to patients, to samples, and to data, which personally I find very boring. But then, you must have learned from Gerrit, no doubt, that it's the boring stuff that matters most. And so, if we have to solve the boring stuff anyway, we might as well do this right. And so in terms of patients, maybe we should not focus too much on the randomized controlled trials, on the homogeneous and highly selected populations, on the academic hospitals. Maybe we should find mechanisms to actually get access to real patients representing the real population. And this is actually what the prospective Dutch colorectal cancer cohort in the Netherlands has solved. So when they started, they start to ask all patients with colorectal cancer for informed consent. Can we use the data? Can we make use of tumor tissue? Can we have some additional blood draws? Are you willing to answer some questions in questionnaires? Can we approach you for new studies? And this has worked out really well. And thanks to the PLCRC team, Frederike is here today. But in a relatively short time span of a little over 10 years, by now there is 25,000 patients included in the Netherlands in PLCRC. And this is a fantastic backbone if you want to do liquid biopsy ctDNA studies. So if you just have a little bit of extra funding and you go to 30 or more hospitals, you can actually start to systematically collect blood samples from patients with non-metastatic cancer, stage 1, 2, 3, or metastatic colorectal cancer. And by now, I think we have collected longitudinally for more than 5,000 patients' blood samples. So I think that is really cool. So what about the data? This topic is something that Gerrit Meijer, as he alluded upon this morning, has been thinking of for a very long time. And at some point in time, I guess it must have been 2011, he initiated TRADE. And he asked me to help out in the molecular domain because, where does it state? End user driven use cases have been defined. The end user should have a very prominent role in this. And I thought this was a very challenging project. I didn't understand it, but I was shipped in 2012 to this Cancer Genome Atlas meeting in Washington. And this is where actually at the bottom it says, lessons to be learned. TCGA sets the example, question mark. So that was my assignment actually. So at this meeting, the most fantastic presentation was from J.J. Gao, and you can look it up online. It's still on YouTube, so you can actually find it. He got interesting questions like, how long does it take to load 3 data points from 100 patients? You know, can you really, this was, look back, it's interesting to see. Anyway, well, here he's talking about these new features. So I guess nothing has changed because I think Ino will still talk about new features. On the other hand, a lot has changed. So you saw the PLCRC sub-studies for ctDNA, and I want to highlight here one of them, the Dolphin study, where we are collecting blood samples in conjunction of clinical CT images. And so we will do ctDNA testing and align with the outcome of the radiology. So what we need here is patient data, blood samples, and CT images. And so to bring those together, then it's very helpful if you have a well-structured data infrastructure in an excellent institute like the NKI-AVL. So we can retrieve the blood samples from the biobank, we can retrieve the clinical data from Castor, but also from the Netherlands Cancer Registry. The images are collected in XNAT, and then you can bring this all together. Piece of cake. If you want to hear the real story, you will find Adria, Mariska, Iris in the coffee break, and then you will hear the story about how this really is in most institutes, including ours. It's a huge challenge, and it's fantastic that we reached this point. You're okay, Adria? Okay. So, the images, this is, I think, something nice to mention in the context of the Dolphin study. The images are collected in XNAT as this archive. This is a multi-center study, so in multiple hospitals in the Netherlands, these images are generated. Then there is this pseudonymization tool, and then these images can move to the central archive and then actually be linked to cBioPortal. And so this is what we succeeded to do. So in general, here's the dashboard. So the real difference with 2012 is I did not have a clue how I would see my study in cBioPortal, the thing that Gerrit already mentioned this morning. It would be so nice to see your study in this tool. This is what is now happening for the dolphin study and for the blood studies in general. Longitudinally was not present in 2012, but it is very, very nice to have it, very important to have. You can see the moments of the blood draws, you can see the moments of the radiology. And in this study, we actually succeeded to actually click through and get to the radiological images. Yeah, how should we think further of cBioPortal? What comes to mind? Of course, on the clinical basis, some already gave a nice example where it's very helpful to use this tool. Hauke, I think you will touch upon the molecular tumor board as an example. I just gave you the example for the translational research. Here, cBioPortal is not hosted by HealthRI, but enabling international research teams authorized access to these studies. How to publish? We may not be able to put our data in the MSK instance because then Trump may be a bit bossy about the data and Europe may not like that, but then Europe should actually come up with an equivalent, and EGA could be an interesting opportunity to see whether they could host European-driven, European informed consent cBioPortal studies. Other things that I found interesting is when I discuss with ctDNA biomarker companies, can you actually offer the data also in a cBioPortal ready format? The answer is usually yes. So there's already one working on doing that, another one that I think should do it. We will get them there. But I think it's very attractive to show them that if we use these tools, that they might as well right away deliver their data in multiple formats, among which cBioPortal loadable. And then there is the question how to move on in Europe. Mentioned this morning, is there going to be one EHDS and 27 solutions? How can you align that all of these countries use the same solution? And one approach might still be user-driven. What if you finally would perform more studies, ctDNA studies, for instance, across European countries, and actually tell people, use this tool because, this is convenient, you like it. Semi-automatically, there should be some level of harmonization of how to get there. Basically, you avoid discussing how to get these data there. You simply offer a solution. And offering a solution also means offering training. And here I'm very proud of our data team, of Mariska, of Iris, of Adria, who have been working very hard on our data to get them in cBioPortal, but you're actually also putting together these courses where you train others in Europe. This is actually, you are here working on a training for our Serbian colleagues, but you're ready to train the rest of Europe as well. So I think that's fantastic. Thank you very much, Nikki, Eno, JJ. Thank you very much for generating such a wonderful tool.
So there's actually time for 2 minutes of questions. So do we have them after seeing Raymond's presentation? Stefan.
Yes, great talk. I was wondering about the imaging integration in the dolphin study. You managed to get the link to the images in there. Are there now radiologists or other imaging researchers actually using cBioPortal as their interface to see the images?
I don't think we are there yet. Where's Denise? But now, go ahead, Denise.
Hi, I'm Denise. I'm the study coordinator of Dolphin. No, we are not using it yet. We are currently in the process of collecting all these images from these different sites. But actually in cBioPortal, you can scroll through the images like you do as a radiologist. And I think you can, in the end, also do like the measurements if you want. That is something that we are planning, that when we are going to analyze the images, that the radiologist can actually go through it and do the actual measurements there.
May actually touch upon another aspect. Once you show your colleagues from different disciplines the data in cBioPortal, their first reaction usually is, but this is wrong. And what I like about it is finally they see the data that they offered themselves, and they did not realize that they were offering data that are wrong. So it's very much helpful in the data curation process from each of these disciplines. See you nodding, so confirmed? Yeah, so, and that's, yeah, very helpful.
Okay, so one question, I saw one from you.
Thank you. I have a very specific question about the XNet imaging. With the DICOM protocol, are you guys able to blur out all the patients' like names and details? Sometimes with the X-ray imaging, you get that patient data. Do you hide that from your researchers at this moment, or like because this is an internal NKI thing as well? I don't know how.
No. So you mean whether the images are pseudonymized?
Yeah.
Yes, the answer is yes.
Okay.
And how that works, Stefan knows much better than I do.
Then I will follow up with him. Thank you so much.
Okay, so next speaking is Ruslan from C4Bio. Oh, and Gisela, welcome. Well, actually, the floor is yours. Goeie, nee, I didn't see it.
Yeah. Hello, everyone. We are a C4Bio, so company of software consultancy company of 3 people. My name is Ruslan. Co-presenting with me Gisela and also Peter. You see all 3 of us on the slide. We located in the Netherlands, but also in US. So Peter moved to US. Despite of our young company, we all of us bring more than 12 years of experience. Actually, Peter started contributing, I believe, when cBioPortal became open source from that moment. And we are proud members of cBioPortal steering committee. So we contribute extensively to new features by development, proposing them first. There is this RFC process, right? And then implementing them. So some of these features we will mention during our talk.
Yeah, so we will be talking about some work that we have done for the Center for Data-Driven Discovery in Biomedicine for the Children's Hospital in Philadelphia. So let's start with the big idea that has been driving most of this work. Well, so you all know that if we want to accelerate cancer discoveries, researchers need to be able to find and to share lots of complex data. And well, cBioPortal is a way of doing that. The issue is that at the moment, what we have is what we see on the slide on the left, which is we have a collection of many cBioPortal instances. However, they tend to be isolated, so it's very difficult for instances to communicate with each other. So the vision is that maybe we can move towards an ecosystem where data can be easily shared across institutions using cBioPortal. Yeah, this can happen in 2 different ways. So first, we would have a federated approach where each institution would have its own instance, but there would be tools available that allow very effortless and seamless communication between instances for sharing public data. Or there could also be a more centralized approach where basically all the data lives in a single place. And well, neither of these approaches is perfect. So in the federated approach, yeah, it sounds very nice, but as you see, there's multiple things going on. So there's a lot of many instances have to be set up, have to be maintained. Everything has to be in sync so that everything works properly. The centralized approach is much easier to manage, but then we come into issues regarding how to deal with data privacy and data security. And well, of course, we are not there yet. We don't really have a fully seamless automatic ecosystem where data can be effortlessly shared. But we have developed some tools that could help cBio portal move in either of these directions. And yeah, even though data sharing is not fully automatic yet, the features that we have implemented allow for data sharing. It's just that a bit of effort has to be also put. So we will now talk to you about some of these features that we have implemented.
Yeah, thank you. So we will start with very first one is data loading, data import. I think we mentioned today an idea that when you want to incorporate smaller piece, right, like patient data, few samples, the process is reload the study, right? So it means like you incorporate these samples outside of the database to the data, you re-upload the whole study. So you drop it basically and load it again. Well, it's okay if it's nightly built and so on, but to make this process smoother, we introduced incremental updates, meaning that you can bring just those delta and start import on those delta where data will flow to the database directly and will be incorporated. No downtime required, so it's faster and more smooth.
Yeah, the next challenge that we wanted to tackle was how to deal with different study views. So if an institution has a really large cohort and for whatever reason they want to make subsets of this cohort available to its users so that they can focus on this particular subset, this was not really possible. So what people were doing to go around this issue was basically, as you see on the top panel, they were creating all the different study views outside of cBio portal and then uploading each of them individually. And well, this results in a lot of maintenance later because you have lots of data duplication. And then when the main study gets updated, then you have to also check whether all the different views that relate to that study are also updated. So, well, for this, we implemented two features, published and dynamic virtual studies, which basically allow institutions to just upload the whole study only once. And then within cBio portal, they can create different views, different cohorts within the study. These can be published and they are also live. So if the main study gets updated, all the views automatically also get updated since they are basically looking at the same data. There's no duplication.
Yeah. Yeah, so and another challenge is data export. I talked about data import, data export, and so there were several things. First of all, export was possible, but you had to provide that you know archive or somewhere in storage attached to the study. But the problem that there could be discrepancy of data, right? What you have in database, not necessarily what you downloaded, and like why I have different version of data. So what we implemented is a study export directly from a database. So what you see is what you get, basically. And another nice feature that come with that you can do export not just on physical studies, but on those dynamic use, virtual studies, if you know the cBio portal speak, right? So you can create your own slice that you like, right? Click download, and you will get this data for analyzing, but also it's in cBio portal flat format, so it's ready to be loaded, yeah, to your own instance. So, oops. Sorry.
Yes, and another challenge was addressing permissions. So yeah, permissions in cBio portal work like as an all or nothing thing. So the whole study has to have the same permissions. So if you would have a cohort for which different parts of the cohort must have different permissions, this would have to be done, the cohort would have to be split outside of cBio portal, and then each one should be loaded individually, and each then would have its own permissions. But now, well, it's still in progress, but we're working on this feature that would allow granular access controls. So basically the study has to be loaded only once. And then within cBio portal, all the different views of the study can be created and different permissions can be assigned to them.
Super. Okay, so there are also two big changes ongoing, actually, and we will hear more. We already heard about ClickHouse and a bit of AI. I think Ino will tell a bit more on that. But nice to be aware about these two big changes. First one, database gets replaced. So MySQL with more analytical, like columnar database. So it means faster queries for user experience, right? It's bigger data set get queried quicker. But we also work on a new importer that perhaps will be improved in that respect, that the ingestion will be quicker.
Yeah, and we're also looking into ways of integrating AI or mostly large language models, because we see, so the cBio portal interface is very rich and there's actually like lots of things that you can do. But for someone who's new, it's really overwhelming. So we really want to users to be able to navigate through the portal using natural language. So hopefully this will make the data even more available to everyone.
Yeah, just to summarize, right? So these features is not the solution, right? It's just technical side of it. We heard more that cross organization or cross-country collaboration requires so many things to be solved. But we're getting closer with these new features. Yeah, thanks to connectivity, improvements to data import and data export, you can easily take data from or upload to cBio portal, right? And there are these new features that based on dynamic views, virtual studies that improve data management. So now you can create live data views, right? Or more granular permissions. So you can organize data more neatly. Right?
Yeah, well, and finally, we would like to hear from you what kinds of challenges you have had with the data sharing. If you have any ideas or any suggestions that could take us closer to the goal, it would be really appreciated. And yeah, if you have any questions, feel free to ask.
So thanks. It was a really nice overview. And when I look at the granularity that you developed, then I really think like, hey, we have this PLCRC cohort. We have basically a giant cohort and then sub-study. So then I am actually getting excited to try this granularity function because, yeah, for management. Okay, do we have some questions from the audience?
This all sounds very exciting. Thank you. I was wondering, how does it then work in the governance? Do all of these developments end up in the main branch of cBio portal, or are these separate add-ons that you need to deal with?
No. So we have this RFC process, right? And it's proposing a change. So even before starting actual development, we actively speaking with different organization in steering committee, right? So, and we agreeing on stuff. So it's agreed, signed, and then we start implementation. And it ends up, of course, in the mainstream. So it's successful. Yeah.
Thank you very much for showing all the exciting new features. I'm very happy that I was presenting before you guys because you tackled a lot of problems that I identified. My question is about the incremental data ingestion. I think that's a great improvement performance-wise. Like I showed before, what's helpful for us in doing full uploads is also that you have some sort of master data management that you can see when a sample has left and when it's reintroduced, for instance. Mm-hmm. Do you have an idea of how you can implement or add something to the incremental implementation so that you can still have a bit of an idea of when samples are actually introduced or excluded from the cBio portal?
Yeah. You still can use multiple studies, right? A study per, I believe, per month. You had it right on your slide, but it can be also one study where you have an attribute, right? That would say sample date or something like that, right? So you're not limited in choices here. Incremental approach should help in both scenarios, actually.
Yeah, great, thanks.
Yeah, thank you very much for this very nice tool. I think that in the sense of federated learning, I mean, this is really the place to go. But I was just wondering about the data quality or quality issues. Different centers probably have different SOPs that do things differently. And this probably introduces batch effects if you're trying to merge data from different sources. Not that you can probably resolve this, but are there any tools you can think or implement that discovers some kind of batch effects or says, okay, you cannot compare maybe this study or this sub-study with the others because of different SOPs? Have you been thinking in this line of data quality?
Data quality. Not sure about that. So this allows to let data to be, but of course, data quality and arrangement on, like what vocabulary to use, what ontology to use. I think this communication should happen, on a certain level. So we don't have necessarily anything feature-wise to enable that, but yeah, that's important, of course.
Okay, so one has to basically first ensure that the data quality and standard operating procedures is basically equivalent and similar across the studies you want to merge.
But of course, we would like to automate these things, right? If possible. So I would say this is important. We talk about already cBioPortal ready format. They should go some QAs, right? And maybe checks.
Yeah.
But that's good. Yeah.
Okay.
It's not part of those features there. Yeah. Yeah. Okay. Thank you very much. Thanks.
So now we will have the final presentation of the morning session. Presenteren. Even kijken. Yes, jij bent het snel mee. Window. All right. Floor is yours.
All right. Thank you, everybody, for joining today. And I'm the last thing between you and lunch, so I'll try and be brief. So what I would like to take the opportunity is to talk a little bit about cBioPortal and how we collaborate as a community around this tool and how that also helps to enable open science. So let me first introduce us. So I'm from the Hive, and the Hive is a company that enables open science by verifying data, and we do consulting in the life sciences. And I think many of you are familiar with some of the work we do. And the tools that we work with are open source, and that's for many of the reasons that are shown on this slide. And I think many of you are also aligned with these principles. So the Hive consists of two larger teams. Part of the team is on data collaboration and integration, as you can see here. So there's things like Odyssey and OMOP in this part of the team. And then the other team that I'm from is the genomics and target discovery team, which also hosts cBioPortal, but we also have, for instance, open targets and other tools surrounding that. And together, these teams, of course, allow us to empower analysis and enable integration. So cBioPortal, I think it's been amply introduced today. So I was also considering, so what am I going to tell you today? Because many people that have been part of the history and part of the whole course of cBioPortal are present today. So what I decided to do today is to describe the type of things that you can do with cBioPortal and the type of things we do. So for instance, we've also seen already today that there's many opportunities for integrating data. Also, non-proprietary data is ingestible into cBioPortal, and there's many different ways of achieving this. This also needs collaboration between the open source community and also, for instance, big pharma companies. And that's why I wanted to show you one of the feature developments that we did last year for AstraZeneca. Essentially what they wanted is a small addition to the Kaplan-Meier plots that are available in cBioPortal. So rather than just use the plot as it is, there was a way to enhance these plots and to make them a little bit more informative as to what they were before. I think the vetting process has already been referred to a few times. Also, this has been vetted through the same procedure, the RFI procedure, which means that the community decides, is this a good feature? Do we need to change this feature? Often there's some feedback on the feature to say, have you thought of this? Have you thought of that? And then in the end, this feature is implemented. So this feature is then commissioned by AstraZeneca. It's built by the Hive. It's approved by the community. It's then merged into the main branch, and now everybody can use this. So this is a feature that's currently available. So this is the actual feature. So here you can see the Kaplan-Meier plot. For instance, the number at risk column that was mentioned in the previous slide, that's been added here. There's the hazard ratios that have been added. And in this way, the plot has become more informative. And this is just one example of a very small incremental change that involves both big pharma, companies such as the Hive, and the open source community for the benefit of the patients. All right. Another thing that we also do is to try and, of course, see if we can bring some improvements to the platform and to see if we can, break the ground and make sure that we go a little bit further. And this is a screenshot of our demo server. And we use it to test out things. We use it to illustrate new features. There's a few studies in there. There's fewer in there, of course, than the public portal. One of the things that I would also like to show you is the AI OQL helper. This is a very recent addition to the demo server. It's in the process of being added into the main branch. We're currently working on that. The idea for this, or the first instance of this, actually came from the hackathon. So earlier this year, we had a hackathon around cBioPortal. So many of the different teams participated. We also participated. This was our project, and we decided to, okay, so let's see if we can, do some AI stuff. Everybody wants to do AI. So that's also what we did. And we decided, let's take it very slow. Let's take a step back. What do we want something that's useful. We want something that's not too black boxy. We want something that we can use easily and that we can also implement and hopefully have out in a limited amount of time. So what we decided is to try and build a chat interface that helps users to do queries with the OncoQuery language. OncoQuery language is a SQL-like language that allows you to make data selections in cBioPortal. For the more advanced queries, this is very useful. But of course, there is a bit of a gap there, because either you have to know this or you have to learn how to do it. And in terms of democratization of data, having this available to more people will be useful. So we decided, let's see if we can have like a large language model do this. And I am going to show you, and I'm actually just like Sam, live demos are jinxed. So I'm going to play the movie. What you see here is studies being selected. Go to query by gene. You go down, and then there's this extra box right at the bottom, which says Ask AI OQL Helper. Then you type in your query. So in this case, EGFR, shallow mutation TP53, IDH1 mutation. You can see here, that's where it generates the query. Works quite well. And then you only have to do is say, click, and then you get the result. So this is the OncoPrint that I think we've seen and featured several times. So you can see that the OncoPrint exactly looks the same. Everything is the same. What you do see, of course, is that in this case, the IDH1 doesn't have any mutations. And that is on purpose, because I want to illustrate that while this tool does help you formulate the query, it doesn't answer your questions. So you need to formulate the questions yourself. You need to think about what you do. And this thing can help you, but it's not going to solve cancer for you. All right. So that's what I wanted to tell you today. Oops, it's going again. We can watch it again. I can also try and do the next slide. That's what I wanted to tell you. Thank you for your attention, and I'm open to any questions.
Love to see how cBioPortal keeps on improving and how you make it user-friendly for people to use the Onco query language, because for me, I found out just because I got two experts who are actually knows about how to deal with cBioPortal. And then it's like, oh, you need to do this, you need to do this. So that AI bot really looks interesting. And this is just one of the few developments. Do we have questions from the audience? Stefan.
Yes, thanks. You mentioned you are also involved in Odyssey. So I was curious, so once you have done all the work to put your data into cBioPortal, can it be easily also mapped to this to the OMOP model that's, I think, more used in the Odyssey world, so that you don't have to start over again?
So that is not done, but that is definitely, so we're definitely getting a lot of inquiries as to, the translation from one to the other. So that's definitely something we're considering and to see how we do that. But it's not ready. No, it's on the horizon, but it's not there.
And do you think they can be easily mapped on each other, or are there like very fundamental differences between?
I think in principle, yes, but I'm not a data modeler, so I would have to consult with some of my colleagues who are more experienced with this.
So to hook into this question, like with Odyssey, I have seen a colleague, I forgot his name, but he was involved in the ACR Genie model, and for 13 cancer types, he already did the modeling to OMOP for data that is in cBioPortal. So I can find I can't find his name, but he was in close collaboration with you guys as well. So people did a lot of work. Other questions?
Thank you, Jan, and great to see these improvements on the Kaplan-Meier curves. I was wondering what else is on AstraZeneca's wish list that that could be interesting for us.
Yeah, so that is always difficult to know what these big pharma companies are thinking. It's always a bit of a dance to try and align these things. One of the challenges is also the timelines. Especially the smaller companies, the bigger companies are slow. That's not much of a problem, but the smaller companies, they tend to be quite nimble. And then the process of getting everything through the community, getting the feedback, sometimes leads to delays, and that can be off-putting a little bit. So that is a challenge, I think.
And then, so I have my history with collaboration with pharma companies and open source solutions with another application. So I was wondering, next to the example that you are giving now, how well this can work out, how much is there also being kept private in developments and add-ons on cBioPortal by companies? And you don't need to go in detail, but I think it would be good to have kind of generic impression on that.
So for the people that we work with, it's very little. It also has to do with the software license, I think. But there are many other companies that are also using cBioPortal that are not really associated with the community. I think also during AACR, some of us that are also here had a tour with one of the bigger data companies. They had their own platform. It didn't look like cBioPortal, but in terms of functionality, let's say there were striking resemblances, quite a number. So definitely they're also looking at it, rebuilding it, using it. So there's definitely that ongoing. It's just I don't think they tell us because we are more for the open science. So.
Thank you.
Any more questions? Going once? Going twice? Then I would say, tijd voor een rekje strekje. Get the stretch in, get some fresh oxygen. Be careful when you walk downstairs because the stairs are missing. And I would say it's on to lunch and a break. We'll be back here at 12:25, so 5 minutes before the afternoon break. Thank you, everyone. And the speakers, of course.